Part of the results is here there is what is called score ranking matrix. Okay, and mean predicted and mean actual, both are used. So mean predicted and mean target. Okay, and we have that for train as well as validate. Okay. So what this is this is like a lift chart, except that you don't find a ratio. Okay, how do you find? How do you set up lift chart? You sort by the predicted y, right? And then you break that list into 10 equal parts. SAS does 20 equal parts, right? So now it is sorted by y hat. Now within these 20 equal parts, you average your y's, your target value, not the predicted value, average of the y, and then you divide by the overall average. So you're comparing, relative to overall average. Okay, how does the top 5% relate to the overall average? So it's twice as much or 3 times as much. The second 5%, what is the multiple relative to the overall average? Third 5%, what is the average, how many multiples of the overall average is this average in the third 5%, and so on. And that's what we did last time here. Okay, so the first 5%, it is almost twice as much as the overall average. The second 5% is 1.6 times the overall average, and so on. Okay, so the same principle, but in a slightly different way. Okay, here instead of using the ratio of the bin average to the overall average, you simply plot the average itself. Okay, don't divide by, it's another way of looking at the same thing. You look at the average in each of them and plot it. Okay, and you do that for both y and y hat. So you have the mean target is the y. Okay, mean predicted is y hat. Okay, so if the predicted y's are very close to the actual y's along the way down, then the prediction is very close to the actual, it's good. Okay, but now if it is like this, look, it is separated now, the actual target is separated from the predicted max here. Okay, so instead of average, you're looking at the max, and min here, it is even more separated. Okay, which max and min are one value in each of them, so there is likely to be more separation. But the mean, okay, that's what is important. And here you see that the predicted y, the actual y very closely follows predicted y, which is good. So the error is not very much. So how do you create these score rankings? So you're ranking the y hats, those are the scores, and then comparing it with y, right? So we have we already have the data. So this is your actual y, and this is your predicted y, exactly. So let's do a pivot table, and we will insert the pivot table right here. Okay, and then we'll bring in the case number, right, and group them what was it, 574, 28.7 is good. I think that will give us 20. I'm
Why not 10?
Well, I'm trying to follow what's in SAS. SAS does 20. So I'm also doing 20. Okay, so here it says, you see, if you look at the output, right way at the bottom, you will see those ranges. So it divides it up into 20 equal number of observations, 20 equal intervals. Okay. So now, you bring in the predicted y and you bring in the actual y. Okay. Now what we need to do is to change the summary to average, and let's change the number format to 0 decimal places. Okay, from here. So instead of sum, we're going to have an average, and the number format is 0 decimal places. All right. Do the same thing for price. Okay, average, okay, number format. Okay, and then we have depth. Okay, going 0 through 100%. So it goes up by 5%, right? So 5% and goes up by 5% after that. So that's your x-axis, and these two are the lines that on y-axis we plot. Okay, so we'll do a scatter plot, okay, like that. Okay. So if you start with the range in a pivot table, you'll get into pivot chart. So we'll insert a blank chart and then we will add the data. Okay, so first data is average of predicted, and the x values are the depths, and the y are the actual predicted values. Okay, so that's one line, and then average target, so that's your average target, average predicted, so that, and y value is that. Okay, so now you have the plot, and you can then format it. So we want to go to 1. All right, and then add a legend. So let's put it in the bottom. Axis, a chart title. So this is ranked target, average, and predicted average. All right. So this is depth. And we don't need this axis, so we'll get rid of that. Okay. So that's what you see here in this SAS chart. And this is for validate, and that's for train data set. We plotted only for validate set. Okay, we didn't do it for the train set. Okay. Now, what we have done here, it resembles the SAS plot very much, but we didn't exactly do what SAS did. There is a slight difference, and that is this. We what we did was we divided the observations into equal number of observations, 20 sets, right? So which is good, which is what your textbook describes. But what SAS does is it takes the range of predicted values. Okay, so predicted values going from 4,214 all the way to 29,088. It takes that range and divides them into 20 equal parts. Okay, so you will have a slightly different type of graph. Okay. I'm just mixing and matching, I guess. I'm following the textbook, but I'm dividing it into 20 parts like it is in SAS. But there are some subtle differences here and there. But both charts give you the general idea of how close y hat follows y, or y follows y hat, and what is the and the lift is the ratio. Okay, so that's what is